Continuing with logarithms, example number 2. Again, we're practicing going back and forth between exponential form and logarithmic form. So what I've done here is I've transferred that first definition over here, the fact that 2 to the third power equals 8, exponential would become logarithmic, log base 2 of 8 equals 3, and here's the pattern. So moving on to example number 2, you see that we now have this log, and you go, easy! The base raised to this power equals this. Oh no! There's not a base. The guy forgot to type the base there. This is a situation where there's an implied number there. And that happens a lot in math where there's things that are implied over 1. You know, things like that. So the question is, when you see log and there's no base specified, what the heck is your base? Well, this leads us to example number 2, Roman numeral 2, on our definitions. This is called a common logarithm. And so when we see log without a base, mathematicians know that there's a 10 sitting down there. And by the way, the language is not log base 10. The language is common logarithm. So when you see log without a base specified, you are supposed to say the common logarithm of 10,000 equals 4. All right, so this would be actually expressed as the common logarithm of 0.001 equals -3, and the words common logarithm tell the listener that there's a 10 sitting down there. So this would be expressed over here as 10 to the -3rd power equals 0.001. Okay, so that common logarithm is one where there's a 10 sitting down there. And so you see in your notes an example of that. The common logarithm of 100,000 equals, the common logarithm of 10,000 equals 4. Realizing there's a 10 down there, that would be written as 10 to the 4th power equals 10,000. And that gets a button on a calculator called log. And if you grab your calculator, and this is where things are difficult, but if you grab your calculator, I believe you'll see a button that says log on it. And if you could please, let's confirm this one. If you hit that button that says log, which is the one for a common, and put in 0.001 and hit equals, it should say -3. Same thing here. That's a common logarithm. That's the function in the calculator. Log, common logarithm, 10,000 equals 4. All right? Now I need to point out that that's not the calculator function if the base is something other than 10. So that will not work for this one, the button, because that's base 2. It only works if it's common. So make sure you remember that. Okay. So 10 to the 5th power equals 100,000. You come over here and you go, okay, that's log base 10. Now your hand starts to write the 10 there, and you go, don't write the 10, hand. When it's a 10, you don't have to write it. It's kind of like our little math secret. So, by not putting a base here, we're actually putting a 10 there. The common logarithm of 100,000 would equal 5. And again, that implied 10 that's sitting down there raised to the 5th power would equal 100,000. You don't have to put the 10 there. In fact, we shouldn't, all right? It's our little secret. There's a 10 down there, all right? It's the way you can tell whether a person knows math or not, the fact that they know there's a 10 down there. So, there you go with that. All right, next one. And I need to make some room. And again, I'm going to take the 10 away from that one. Okay, I'll leave it there. All right, it's a training wheel. I'll leave the 10 on that one. Okay, this next one. We give you a logarithm. It says ln, and we need to talk about what that means. This is a different symbol than this, log. That's not a 10 down there. If it was a 10, it would say log. So this is what the mathematicians of the world call a natural logarithm. That would be definition Roman numeral 3. Its base is what we call the natural number e. Now most people are familiar trying to build on something you're familiar with. Most people are familiar with pi, 3.14159265358. I can go on, I'm out of room, okay? And the fact that on March 14th every year we celebrate Pi Day, okay? E, similarly, is a symbol in math for a number. And unfortunately, a lot of people are less familiar with E. It's called the natural number, and it is approximately 2.71828, blah, blah, blah. It goes on forever just like pi. I've always thought, therefore, that on every February 7th, we should celebrate E Day. And some of us do, all right? But anyway, it's a very important number in math. It has a lot of applications. And when we see the symbol ln, that actually means that the base is E. And since E is called the natural number, this is called a natural logarithm. So the way we would say that is the natural logarithm of 863 is approximately this number here. And again, once we realize that that base is E, then it follows the same pattern as far as E to this power is approximately 863. So it's the same pattern. You just have to realize what your base would be. And again, we have an example of that in your notes. The natural log of this number is 5.4, which would translate to e to the 5.4 power 221. Most calculators have a built-in natural logarithm function. It's very difficult to talk about this because we're obviously far away from each other. But if you wanted to calculate the natural logarithm of 863, I bet you your calculator has a button that says ln on it. And you hit that there button. And if you hit ln 863 and hit equals, you'll see it's approximately 6.7604. Now on the flip side of that, if you wanted to take e to a power, like this relationship is expressed, I'm sorry, my words aren't coming, e to that power, I would point out that most calculators have e to the x, which would be the second function of that, which is usually color-coded, yellow, red, whatever. And if you want to raise e to a power, you probably have to shift or second function, call up that e function, and then put your power in. So I invite you to practice that. My guess is your calculator doesn't have e on a button, it's above it. It's a second function. You have to access it with a shift or a second of some kind. So shift e, put in your power, 863. All right, so it goes both directions like that. If somebody says that e to the third power is approximately 20, etc., and by the way, if you were going to check out that relationship, I hope you would say, okay, if I want to put e to the third power in a calculator, and this is an educated guess, I don't know what your calculator looks like, but I bet you e to a power is not on a button. Again, it's a second. You have to shift or second. If that's red, it's probably a red button somewhere on the calculator that shifts it, or yellow or green. And what color is your e to the x? Blue? Oh, okay. Green? Okay. Mine's yellow. In the notes, it's red. Whatever. They're usually color-coded, but you would shift e, put in 3 equals 20, blah, blah, blah. Okay. Now, when you change these over to logarithmic, I know it's tempting to go log base e. You gotta go bad hand. There's a special symbol for log base e. This isn't really how you write this. Log base e is written as natural logarithm. All right, so let's not write log base e. It's ln, the symbol that represents log base e. And then following the pattern we've established, that would be of the 20 blah, 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 approximately 3. Same pattern, base raised to power equals anti-log, the logarithm dance. Okay? And again, writing ln implies there's an e down here. So that's log, you don't put the 10, that's ln, you don't put the e. You get the idea. All right. There's a couple more here. I guess we'll do them while we're here. I just put these last two in because I had room and I just felt like messing around with symbols and stuff. So again, hit pause if you need to. I've got to make room for these last two here. So I suppose I should not have erased my top one there. Let me put it back. This is just kind of my reminder of how the pattern works. All right, you don't know what these symbols are. There's some Greek letters and some symbols we use in logic. But look, you don't have to know what they mean to understand the question. I hope you would just simply say base to this power equals this. And even though you don't know what them there things are called, I hope you go, well, that squiggly deal raised to the backwards e power equals upside down a. That's not what those symbols are called, but that's fine. It's pattern recognition more than anything else. And then if somebody said, horseshoe raised to the circle with a slash through it equals triangle, those are Greek letters, okay? We can talk about what they are if you want. That's omega, that's theta, and that's delta, whatever. Triangle, horseshoe, I don't care. The point is the pattern would be log, base, horseshoe, yep, it's omega, of triangle, yep, delta, equals that there circle with a line in it, yeah, theta. You don't have to know the names of these in order to know where to put them. I had somebody one time go, I don't know the Greek alphabet, I can't do that question. I said, you're not getting the point of it. So anyway, I think that's example 2, and I'm hoping that you're finding these to be fairly easy. And all right, let's move onward.